I'm gonna...
Hello, everyone.
Hey, everybody. Welcome back. Good to see you. So while we wait for maybe some more people who might be running late, we can hang out over here. Welcome back for those of us who are regular viewers, or welcome to the stream if anybody's new here. Feel free to drop in the chat and say hello.
Yeah, hello, everybody. Just making sure we got all our audio working here.
Yeah. Let's not have a repeat of some of those other times where my audio has... Let's not think about that.
I think we're looking good now, though.
Sweet. All right. Well, hey, everybody. Welcome back to the Fall Dome to Home series. If you're new here, my name is Rémy. I'm an astronomy student at CU Boulder and a presenter at Fiske Planetarium. And below me, we've got...
My name is Jeremy. I also work at Fiske Planetarium. I graduated from CU Boulder a couple of years ago. And now I work on education programs, doing presenting and navigating. So everything you see over here on the dome, I'll be doing live using our planetarium software virtually. Obviously, we're not in the planetarium, but we're bringing these shows to you guys. And of course, Happy Halloween coming up. We got our little Mars jack-o'-lantern all queued up.
The Mars lantern we worked really hard for.
Yeah, in a previous life, I was a very, very bad artist. So
graphic design is Jeremy's passion.
Exactly. I was able to channel that a little bit,
Yeah. So also helping us, we have over in the chat, Amanda, who is our chat moderator and question master for the day. So if you have any questions or comments, feel free to drop them in the chat, and Amanda will either answer them or send them our way. So we'll also have time to take your questions live at the end of the show. So assuming you're watching this live. So if there's anything at all that you're curious about, ask it when it comes up, or at the end, you can save it there, and you have 3 experts ready to help you out. So don't hesitate to ask any questions. So today we are continuing our Perseverance to Mars series. We're going to be learning about Mars's seasons and climate. So when we hear the words climate and seasons and things like that, we think of like leaves changing color in the fall, or snow in winter, or rainy springs, hot summers. We think about weather and clouds, and overall we think about Earth, right? Because that's where our experience lies, on Earth. So that's generally what we think about. Earth isn't the only place with weather and seasons and climate, though. It's certainly what we're most familiar with, living here and everything. But what causes seasons here on Earth also leads to seasons elsewhere. So let's take a look first at what causes seasons and climate here on Earth, and then we can see about how we can apply that to Mars and even to other planets. So the key to all of this whole system here, is actually the sun, not necessarily the Earth, but the sun. So it all comes back to the sunlight a planet receives. So if we take a look at the Sun-Earth system, we can see maybe a little better about what I mean. So really common misconception is that seasons are caused by how close we are to the sun, like summer when we're closer and winter when we're further away, but that's not true. So although the Earth is sometimes closer to the sun because our orbit is not a perfect circle, the difference isn't nearly enough to cause seasons. So what causes the seasons is actually the tilt of the Earth, which we can see there with that arrow. So the Earth is tilted. So instead of like straight up and down to where it's orbiting the sun, it's tilted about 23.5 degrees, like this. So you can see right there. We can know where the Earth is tilted because we've got an arrow sticking up out of the Earth. You just got to look for the arrow. That's not true. So here we go. So we can kind of see what it looks like the sunlight that it receives based on this tilt. So I think we have a chart in here of that.
Yeah, let me go ahead and bring up this guy for you.
Yeah. So the amount of sunlight that an area on Earth receives does vary throughout the year. So you might have heard about how winter at the North or South Pole is completely dark all year round. and completely light all year round, or not all year round. During the winter, it is completely dark. During the summer, it is completely light. And this is why, because it's tilted. So sometimes, you're tilted a little more toward the sun, the northern hemisphere, and sometimes you're tilted away from the sun. So you receive more or less light like that. So it's not just the amount, though, it's also the angle that's important. Oh, there it is a little bit bigger, so you can kind of see how much sunlight you're receiving. And that's also why you have opposite seasons in the northern and southern hemisphere. So what's also important is the angle of the sunlight that you receive. So you can see near like the equator and places near the equator get really direct sunlight, really hot sunlight. When it's around noon and you're standing right under the sun and it's really, really hot. And it's a lot hotter than when it's morning time or evening time when the sun is kind of from the side. So that's kind of what's happening here. When you get over to the poles, the sunlight's much less direct, so it's much less intense. And that's why even in the summer, it doesn't get super, super hot at the poles. So we can kind of see how that works there. So the sun does also do more than making a place, hot or cold. It also warms up the atmosphere that we have unevenly. So it's what causes things like atmospheric circulation. That's just the air moving around the Earth. And it leads to some areas of the Earth being more wet and some being more dry. It leads to winds and clouds and storms and all sorts of weather. And then what climate is just kind of an average of weather. So you look at all the weather over a given time and you kind of see what a place's climate is like. So it's just the average type of weather that you get. So, winters are usually cold, but sometimes the weather on a given day might be warm enough that you don't need a coat. So that's kind of the difference there. But what about Mars? We're talking about Mars. Does Mars also have seasons and climates? The answer is yes, or else this video would be pretty boring and very short.
We're bound to find out in this video, huh? That's
let's find out. Let's learn more. Let's head to Mars and we'll take a look. And as we do so, let's think about what Earth has that gives it a climate and season. So first we need a planet. Done. Mars is a planet. Next we need warmth. There's the sun. We've got that covered. We also need an atmosphere to hold and circulate heat, which Mars has. It does have an atmosphere, though it is a really thin one. It's about 1% the volume of ours. It's enough to kind of keep in heat and move it around and have things like wind. So we can check that off the list. For seasons, we need a tilt. Mars also has that. It's about 25 degrees, so a little bit more than Earth. And while we're out here, let's take a look at one big difference between Earth and Mars. There are a number of differences, but let's focus on one. So if we fast forward time a bit.
Yeah, so I've made the planets about 5,000 times larger than their actual size. And we're upside down right now. Let me flip us around. There we go. And then I'm speeding up time, going way, way, way fast. We're moving about a month every 2 seconds. So you can see the Earth and Mars orbiting the sun over the course of the year. And you see Earth is closer into the sun, and so it's moving around, it's orbiting the sun faster than Mars is.
Yeah. So think about what that might mean for Mars's seasons if it's taking much longer to go around the sun. If you have a guess, you can go ahead and pop it in the chat there. So if you've got a year that lasts a lot longer, and a year is based on how many seasons basically you have, right? So if a year on Mars is 687 days instead of 365, you split that up, the seasons are much longer and they don't match up with Earth's. So just because it's spring on Earth doesn't mean it's spring on Mars. And although it really does have seasons, when we think about Mars, we don't really think about seasons. We usually picture something more like this. There it is. So these are some pictures of the surface of Mars. And when we look at these, what do we think? It looks kind of familiar, right? We look at it and we think maybe dry, barren, dusty. If you've seen places like this on Earth, if you have, let us know in the chat where they are. I think of places like Arizona or New Mexico, Nevada, places like that are really dry. There's just nothing there. So we look dry, barren, dusty, and you might also think hot because, you're thinking of deserts on Earth. It's pretty hot. And when we think of like red, we think hot, but that's not the case on Mars. Mars is really cold because it is much further away from the sun. really, really far away from the sun. So it does get a lot less heat. So it is a lot colder. So those deserts there are not as hot as you might be thinking. So let's actually take a look at Mars's temperatures, kind of see what the temperatures look like on Mars compared to Earth.
Sure thing.
Yeah.
So we're zooming up over here to Mars now. Here we're coming up here, and I'll bring up this little graphic that shows the temperatures of Mars, the kind of average temperatures compared to Earth. Rémy, you can go ahead and explain this chart maybe a little bit more.
Yeah, for sure. So you can see here, the one at the top is the temperatures for Earth. So those are the extreme temperatures for Earth. The hottest recorded temperature, 136 Fahrenheit. The coldest recorded temperature, negative 126 Fahrenheit, which is a pretty big difference. The average temperature on Earth is about 57 degrees Fahrenheit. So if we look at Mars, though, it's much colder. So, you've got the highest recorded temperature was 86 Fahrenheit, which is pretty abnormal. The lowest recorded temperature is negative 284 degrees Fahrenheit. That's really, really cold. And the average temperature on Mars is negative 81 degrees Fahrenheit, which I keep saying it's very cold, but y'all, it's cold. So Mars being much further away, it's a lot colder. One thing you'll also notice is the extreme difference in temperatures. And there's an extreme difference on Earth too, but these are kind of global averages, right? This is over the entire globe. So let's take a look at one spot in particular and how the temperatures vary.
Alrighty, so I think we're going to be going to Gale Crater, is that correct?
Yes, we're going to head to Gale Crater, where Curiosity has been taking some weather measurements for quite some time. So we've got a pretty decent amount of data on the temperature there.
All right, so when we're flying around to Gale Crater, I've added these two lines showing kind of the North Pole and the South Pole of Mars. So just kind of like Earth, how we have the North Pole that's, tilted a little bit. This yellow line, the North Pole of Mars, is also tilted, pretty close to the tilt that Earth has. I think it's about 24 degrees.
It's 25, yeah.
25 degrees compared to Earth's, which is 23. So a pretty similar tilt. And let's see, we're getting over to Gale Crater. Let me tag it again.
Yeah.
There it is.
Dun, 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 dun.
And as we zoom in here, we can bring up a nice panorama. Ooh. There we go.
So there is the desert, which is Gale Crater. It didn't used to be a desert, though. It used to be a lot of water there. We actually have some videos on that as well. So Gale Crater is where Curiosity is right now. It's been taking a lot of weather data, so we can take a look at what that looks like. So here's just in one location, the variation in temperature. And you'll notice not only is it much colder, and it's compared here to Los Angeles on Earth. So you'll notice that not only is it a lot colder, there's also that huge variation still. So it's not just that the whole planet has a big variation, even just in one place. So the reason for that is because it doesn't hold as much heat. So this thin, dry atmosphere here, it doesn't stay as warm. It doesn't hold as much heat. So it cools down a lot during night. And that's why you end up with this really big fluctuation here. We also see, it goes up and down like a wave there. That's because of seasons. So, sometimes it's hotter on average, sometimes it's colder on average. You can take a guess on when it's summer and when it's winter in this. But that's also the reason why on this graph, we have it just labeled by seasons, not by time, like by month or anything, so that we can compare a little bit better. What seasons look like in Gale Crater versus Los Angeles. Otherwise, they'd be totally out of sync. So yeah, here we go. And you can see it's really cold. It's generally below freezing, even in the summer over in Gale Crater. So another really neat seasonal pattern that we can see on Mars, aside from just temperatures going up and down, is on its poles. So you might have seen how on Earth, when it's summer in the northern hemisphere, the ice cap the ice cap melts quite a bit. And then when it's winter, it gradually gets icier again, and then it repeats. So Mars also has ice caps. So we can take a look.
Orbit on up there to the northern pole. There we go. Looks pretty similar, huh? Something like I know, maybe a little bit close to home.
Close to home, dome to home.
Aha!
Ha 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 ha. So Mars has ice caps as well. And we do actually see the same pattern. So if we take a look at, do you remember the diagram of Earth going around the sun? We can also going to take a look at, this diagram here. It looks really similar, right? You've got the tilt, you've got it going around the sun, and you can see how it changes with that ice cap, right? So this isn't just something that we've been like thinking about, that we assume, oh, I bet the ice cap moves. We do also have like pictures of this. We have evidence and data. I think we have some pictures from Hubble, right?
Yeah, so this is a picture taken by Hubble. I want to make sure I got the dates right. I think it was, October 1996, then January 1997, and March 1997. So over the course of a couple months, taking images of that north polar cap. Let me see if I can make it a little bit bigger for you guys here. And you can see that the ice is shrinking over the course of these observations.
So you can take a guess on when is winter, when is summer. And I promise it does come back around. It didn't just leave. So yeah, we do have, data that shows that there are these seasons on Mars. These ice caps aren't just permanent. And this ice, I want to mention, by the way, it's not water ice like our ice caps. This is actually frozen carbon dioxide. So this is dry ice like you use for fog machines for Halloween, spooky. See, I can bring in Halloween as well.
Ooh.
And I think you said you had kind of a neat video to show, right?
Yeah, so this next video that we'll go ahead and show here. So this is a simulation that was done on the left panel here. Over here, the far left, we have kind of a top-down view of the northern pole, and then on the right is kind of the southern pole. And so what was done for this simulation is there was a bunch of infrared measurements taken of the North Pole and the South Pole, of measuring how the ice is growing and shrinking over the year, and then they combine those to kind of make this animation or make this video of what the polar caps are doing. And so this is pretty similar to what we see on Earth. Over the course of the seasons, we see the ice caps on Earth growing and shrinking as well.
And like you said, this is infrared. So this isn't exactly what it looks like. Infrared can tell us the temperature. So it's a computer animation here based on the temperature that we see. And we just added the colors they added the colors, we didn't, to show us what's going on so we could see that better.
Yeah.
So we also have, aside from just temperature patterns and ice caps, one of the biggest seasonal events we see are dust storms. So Mars has a fair number of dust storms and dust devils, and they look like little tornadoes. I don't know if anybody has seen like a dust devil or has even seen a tornado. Let us know in the chat. That's pretty neat. But Mars has them all over, and it's usually like a spring, summer thing that they have them. I think these pictures are so neat because you can see even the shadow that these are like definitely sticking up in the atmosphere, that these are dust storms and dust devils. So I also want to note that they aren't very strong. So while there is wind on Mars, these winds and dust storms, they aren't very strong. So like if you've seen the movie The Martian, where that whole like wind storm comes in and blows everything over and it's really intense, that really wouldn't happen like that. Because the atmosphere is so thin, the wind isn't that much. So you get these cool little dust storms, specifically, like I said, in spring and summer.
We've also got this nice dust devil that you could see that Curiosity actually captured, which I think would be maybe be a little bit scary if I was a rover just hanging around on Mars and I looked out and I saw this dust devil just kind of moseying along, but doing its thing out there.
I'd be a little spooked.
It spooked me a little bit.
Yeah. So we've got a question here. So we had a question, does Mars go through global warming? So Mars does kind of like, so you can have, well, global warming, climate change is just a change in climate. So Mars has gone through a climate change, especially when like it lost atmosphere. Then it definitely went through a climate change. So it was probably much warmer when it had a thicker atmosphere and more atmosphere. And I think things like that are mentioned in the video from last week. So there isn't any evidence of like a full global warming event like we've had. So not quite, but yeah, sure, a little bit. I don't know, Jeremy, do you have something to add to that?
Well, I think it doesn't really have global warming in the sense that we think of. And I know a lot of things that sometimes I think of is a lot of people, when you think of global warming, you think of high CO2, rising CO2 concentrations in the Earth's atmosphere, right? And so a lot of times it's kind of confusing to think about, well, if Mars has so much CO2 in its atmosphere, it's mainly CO2 in its atmosphere, why is it not very warm? And it's mainly because of the atmosphere being so thin, it can't really hold on to any heat in its atmosphere. It goes through those big fluctuations. I think in terms of long-term scale global changes, global climate changes, I don't know if we've been studying Mars long enough, and I don't know if we have enough evidence and like enough kind of actual measurements to be making claims like we can here on Earth. We have enough measurements where we can know on Earth that the climate is warming. On Mars, I don't think we have enough measurements yet.
Yeah, a lot of people, when you ask which planet do you think is the most studied, people go, oh, well, Mars. Earth is actually the most studied planet. We have the most data about Earth, so it's really tough to say really what's been happening on Mars. There's a ton of stuff that we can figure out and extrapolate, but we just don't have any evidence of that. We also have a question from Denise, who wants to know about severe seasons maybe causing issues with planned Mars missions. So we don't really send them to really intense areas. Like we don't send them to the ice caps just yet. It's something they take into consideration when you're going to send something over there. But the main thing that you think about when you want to send anything to Mars is, where is Mars compared to Earth? What's going to be the most convenient way to get to Mars? And then like weather and seasons is kind of secondary to that. Then we also had a question about from Mr. McFarland about Coriolis effects, patterns like trade winds and bands of discrete latitudes. So what Mr. McFarland is talking about is when you have like an atmosphere on a planet and then the planet's spinning, you end up with like certain wind patterns, the way that works. So on Earth, you can kind of see like bands of wind and wind patterns and the way that the atmosphere moves. Any planet has an atmosphere and is spinning is going to have like winds and Coriolis effects. But this atmosphere is so thin that it's just not quite as pronounced as far as I'm aware. Actually, since we're talking about like planet winds, what's really neat about Mars is these, it gets planet-wide dust storms. Yeah, there we go. Jeremy's on it. So not only do you get like the small dust storms and those dust devils, you can get a dust storm that covers the entire planet, and they happen every few years. This one is from 2018, right?
Mm-hmm.
Yeah.
Yep.
So this is the dust storm that killed Opportunity, actually. So this dust storm just covered the entire planet, and Opportunity, which was solar powered, ended up getting covered in the dust, and the wind just didn't blow the dust off later, and that's how we lost Opportunity. Yeah. So this is Opportunity's killer. Go ahead and direct the hate toward it.
Yeah, on the left there you see images of Mars before the global dust storm, and then on the right, obviously, with the dust storm. And we could take you down to the surface of a different dust storm. This is what Curiosity saw. I want to say, I'm not going to say the year because I might mess it up. I thought it was maybe 2012, but that might be wrong. But this is just the left panel.
5 year redacted.
The left panel is taken 3 days before the right panel. So you can see how some of these bigger dust storms can really start accumulating and kind of really grow to become big monsters. And then this is kind of a simulation of what that would look like if you were actually looking at the sun in one of these dust storms on Mars, going from left to right as that storm progresses. And that's the big issue with rovers that use solar power. Usually, the plan and why a lot of these rovers can continue in their missions is it makes it through the dust season, and then it kind of just light winds as the dust subsides kind of knock off all the dust from those solar panels. But if the dust season is too strong, too large, then it's just the winds aren't really strong enough to knock off all of that dust. And so there's kind of a lot of ideas for the future of maybe it'd be easy if we were there, right? We could just simply put, an astronaut could walk out there and just knock off the dust with their hands, but obviously we're a little bit ways away from that. So there's been a lot of thought about maybe somehow like shaking vibrating the solar panels gently, but hard enough to knock off the dust. There's still a lot of work kind of going in to figure out how we're going to figure these dust storms out.
And it looks like Amanda tracked down those photos before. They were also from 2018, so same dust storm.
There we go. Yeah. Same one.
Yeah, and they aren't really all that close to each other, so that just shows that dust storm was everywhere. Like Jeremy said, though, overall, we don't really have a ton of understanding about that sort of thing, and we only have so much data on weather and climate on Mars, especially compared to Earth. We've got temperature readings. They only go as far back as we've had instruments on Mars, which is way less time than on Earth, and we certainly haven't covered the entire planet. So understanding interesting weather like this is a goal of Perseverance. It's equipped with an instrument called the Mars Environmental Dynamics Analyzer, or MEDA, which will take lots of measurements of weather environment while it's out there. So getting a better understanding of weather and of climate, and hopefully of past climate as well, can tell us a lot about habitability. So whether Mars could have held life in the past or currently, because a proper climate that isn't too varied or too extreme is really important for developing and harboring life. I do want to make sure that there it is. The MEDA instrument is right on there.
Yeah.
I do want to make sure that we've got time for any other questions that you might have. So if there's anything you're curious about, go ahead and drop it in the chat. I'm pointing over there because that's where the chat is, but it's probably over here or over there. No, there.
Down to the side.
Down. Is it down? Is it over? It's around
on the screen.
The chat is somewhere in some direction. Feel free to drop something in there, whether it's a question about what we talked about with Mars's climate or climates in general, Mars in general, maybe just a space question that you want answered. Just let us know, because we are answering them live, assuming you're watching live. And if you're not watching live, come back when it is live so we can answer yours.
Yeah. Seasons are, they're useful. I know Rémy and I were having a conversation when we were planning the show, trying to think about what the reason we were talking about the seasons were. And I think a big thing is that Perseverance is, like so many rovers that we have on Mars right now, are searching for, evidence of past life. And so if we sent a rover to a certain location, we want to think about maybe, what the seasons were like in that location. That has an impact on where we decide to send these rovers. It wouldn't make sense to send somewhere, or it depends on what we're trying to find, right? Based on where or what we're trying to find has an impact on where we would like to send these things.
And we've talked a bit about why we're sending Perseverance where we are in some of the other videos. I think planning the mission is one we talked about that in, for sure. I think we also talked about it in Life on Mars. I think we've talked about it in a lot of ours, actually. While we're waiting, a question that I've had a few times is about Mars's atmosphere it's pretty much mostly carbon dioxide, CO2. Which is a primary reason that we have climate change here on Earth, the carbon dioxide emissions. So the question is, if Mars's atmosphere, is all carbon dioxide, why isn't it hotter there, like it's getting hotter here? And the reason for that is just that it's so much thinner and so much further away, and it is actually losing atmosphere. So it's not getting hotter. It's not like there's more CO2 being added to the atmosphere. And it's just so thin that it's only retaining so much heat. But if it wasn't CO2, if it was something that didn't retain heat as well, then it probably would be even colder.
Other climate questions, climate, Mars, seasons, any burning
Keywords,
questions?
climate, Mars, seasons.
Rémy, how accurate are some of the movies with dust storms?
Well, I talked about The Martian earlier today, which wasn't particularly accurate. It's a really accurate movie in so many other respects, but just that one. And I read a book one time about when you're doing movies like that, you have to grant like one miracle exception that sets everything in motion and makes everything else work. And I think that was their miracle exception to have a dust storm actually cause that kind of damage. We've got a question from Denise again. We've got, when is the first manned mission to Mars going to be? Great question. They're saying like what, 2030s? Isn't that their goal?
Don't quote me on that, but I know that the Artemis mission, the twin of Apollo, it's our NASA's new mission to get us to the moon first and then to Mars. So we want to establish boots, get boots up on the moon, and kind of further our technology from the moon first, and then go to Mars. So I think we want to get to the moon by 2024. I want to say.
Let's see how it goes with the moon.
I think 2024.
And then we can jump from there.
Is the plan to have a more cohesive setup on the moon, and then I would want to say maybe 6 years. Did you say 2030?
Yeah, I think it's like 2030s is what they're looking at.
Maybe to get to Mars.
Timelines like this are kind of tough. A lot of times they end up getting pushed back.
Yeah.
I hope.
Yeah, but you can look it up. The Artemis mission and Moon to Mars is kind of, if you just Googled Moon to Mars mission, it will pop up.
Yeah, it's going to be some pretty cool stuff. It looks like the chat has died down. There aren't very many questions, and sorry, I saw a message here. So Amanda's letting us know those dust storms, those like big, huge planet-wide dust storms, they do usually occur when Mars is closer to the sun. And that NEDA instrument, its big thing is to kind of figure out why that happens, because, like we were saying, it's just kind of a bit of a mystery. Oh, and right as I was about to wrap up, so are there any weather satellites left in the atmosphere orbiting Mars, asks Mr. McFarland. So not in the atmosphere orbiting Mars. They're much further away, but we've got satellites that take data about weather and pertaining to weather. Like the Mars Reconnaissance Orbiter takes a lot of data. We've got MAVEN, which is a CU mission, which takes a lot of data on how the atmosphere is changing. So we've got a number of like instruments that take weather data. Most of them aren't necessarily just dedicated to weather, aside maybe from MAVEN, which is dedicated more to atmosphere. Unless I'm wrong, correct me if I'm wrong, because usually when we want to send something to Mars, we try to make it as like multifaceted as possible, see just how many things we can do at the same time. So I don't think there's anything specifically dedicated to it. Jeremy?
No, I think you explained that pretty well. We have a couple kind of lingering things that are still taking, some measurements. Like MAVEN does make a lot of measurements. One of its instruments makes a lot of measurements on, dust storms, and like the IUVS and like the aurora of the atmosphere and things like that. But we don't have a lot we don't have a lot of ground missions that are still taking weather data. And so really to get, humans to Mars, we want to know, how the atmosphere, how the weather is, reacting up high above the planet, but we also want to know what's going on down on the planet. And then we want to know what's going on between those two, right? So I know the InSight mission that is on Mars right now is taking some better weather measurements, such as like wind speeds, wind directions, and then the MEDA, MEDA on Perseverance is going to be making a lot more measurements like that. So hopefully over the next couple of years, we can continue to gather up a lot more of these measurements and get a better kind of meteorological, weather system of what's going on Mars, because if we can get better at predicting kind of some of these dust storms in particular, that will make traveling to Mars for humans much easier.
Yeah, absolutely. And then in regards to satellites, we do actually also have a number of satellites that don't work and are still orbiting. And then a lot of the satellites that we sent will eventually stop working. I mean, Viking 1, though, it was launched in 1975 and its orbit decayed in 2019, last year, that was only last year. And then you've got Mariner 9 that's going to go down in 2022, but they last a long time. The Global Surveyor, it's going to go until like 2046. Well, it'll be orbiting until then. We'll see how long that goes. So that's pretty exciting. Keep an eye out on that, but that's why we have to keep sending more satellites over there. They don't last forever.
Mm-hmm.
But if we don't have any more questions, then let's definitely wrap it up. I had fun here with you all. I hope you guys had fun and learned a few things here. Thank you so much for joining us. As always, if you enjoyed this, definitely like the video and share it with anyone you think might have enjoyed it as well. And if you have any other questions that pop up later, feel free to leave a comment. We'll come back next week. Next week, we're going to be talking about the actual launch of Mars 2020 that carried Perseverance, and that's going to be with Tara.
Ooh.
And don't forget to subscribe to our channel and turn on notifications if you don't have those on so that you can get alerts when we post more videos like these. From everyone here at Fiske, thank you so much for joining us. Bye.
Yeah, thanks everybody. Have a happy Halloween.
Yeah, happy Halloween.